All right, everybody, welcome back. This is the third part of our demonstration for the threaded shaft project for Machine Tech 210 at Laney College. Last time we finished stage one, what we're calling stage one, which was facing the two ends, putting centers in them, and then finishing these outside diameters to these lengths, 1 inch and 3 inch. Today we're going to be working on stage two, which is this print right here, and that's grooving and chamfering. Okay, so we're going to be putting those two grooves in, and then 1, 2, 3, 4 chamfers, 2 different sizes. And this is all the preparatory work that we have to do before we can go in and actually thread these 2 diameters. This is the project planning worksheet. I'm not showing you what the speeds are because that's something you should have figured out yourself. But here you can see all the tools we're going to use. You can see all the sequence of operations. So we're going to be setting tool heights first of all because we're going to be switching out our tools now. So we're going to be doing the grooving tool and the chamfering tool, and we are done with the right hand and left hand turning tools. Okay, we'll square the tools to the part. Okay, so both of these, the grooving and the chamfering tool, are considered form tools. And so their orientation relative to the part is actually much more important than it was previously for those single point cutting tools. Okay, then we'll do one of the grooves, do the other groove, 2 of the chamfers, and then the other 2 chamfers, and then we're done. Now, before we get started, there's something that we need to discuss here with this center, with this whole fixturing arrangement that we have here between these 2 centers. Let's say that I just started machining this stage of the project directly after machining the first stage without breaking down any of the setup. Well, there's no problem with that, and I could just continue working, right? But let's say that at the end of the day, I only got so far and I need to break down my setup and clean up my machine. Well, I'm going to have to remove this from the machine, right? Then what happens when I put it back in? Is it going to repeat perfectly? Well, I think you can see where I'm going with this, but I'd like to prove it out to you. Okay, so let me set up an indicator. Okay, so there I am at 0. When I spin this, you can see that the indicator doesn't move at all, right? Because that cone is perfectly concentric to the spindle axis, right? It's running perfectly true. That's what that means. This is what we want, right? This is what's going to give us that repeatable fixturing, right? If we take the part out and we put the part back in, as long as the 2 centers are good, it's going to repeat perfectly, okay? But what happens if I remove this center? Let's see that. I take it out, and I put it right back in. Okay, lock it back down nice and tight. Put the indicator back on. Okay, now let's see what it does. All right, now you can see that it's running out. It's running out, let's see, this is the furthest point there. About, I don't know, from my vantage point, it looks like about 1 1/2, 2 thousandths. Okay. So now that means that when we put our part between those centers, this side is going to be running out a little bit. So what's going to be happening to our part, right? This side is going to be wobbling around, and this side is going to be held stationary. And so when we turn this thing on, it's going to start wobbling around like this, right? It's not going to be, on all those diameters that we just spent all that time machining, they're all going to be running out now relative to the spindle axis. So it's going to be really, really difficult to go in there and put additional features in here that have to have specific relationships to all the other features that are already on there. Right? It's going to be very difficult to do that if it's all wobbling around like that. Now, we could go back in and take a cut on all these diameters, and that would true them back up to whatever weird wonky axis this is, right, that we just defined with our out of position center, right? But why would you want to do that? Because then when you take this out and you put it back in, now it's not going to repeat again. The only way to get this thing to repeat every time is to make sure that this center, the dead center in the spindle, is always running true. Okay? And that means that if we ever take this out and put it back in, we have to take a skim cut on it just to true that up. Now it doesn't have to be a big cut, right? It's just enough to true it up, right? Just so that you take a cut everywhere on that surface. Okay, that looked pretty good. One good way to know that you have for sure taken a cut across that entire surface is to just blue it up, right? That way, when you take a cut, if it removes all of the blue, the dicum, then you know that you cleaned up that entire surface, okay? Easy way to do it. So you're nice and slow. Looking pretty good. Okay. Yep, looking pretty good. Okay. You can see it doesn't take that long, right? But it is super important that you do it. Okay, so what angle do you set this to now? Again, it doesn't really matter at this stage of the game. I just by habit always put it to 29. That way it's where it needs to be when you go into start threading things, which is the next stage, by the way. Okay, let's see if it cleaned up. Is it running true now? Let's find out. Yep, running true. Okay, so that's all you got to do. It's a good lesson that you can always true up a surface just by taking a cut on it in the spindle, right? Then it will run true to the spindle axis. But if you just put it in, especially into a 3-jaw chuck, which doesn't repeat perfectly, then it will not run true, right? And then all of that error, all of that runout is going to transfer to the part, okay? In terms of the misalignment of the features, that's not good. It's not what we want. So this is the grooving tool right here. It's got a steel shank and it's got a little piece of tungsten carbide that's been brazed to the end of it. And this is something that we can resharpen, right? We can resharpen this. We have to use like a diamond or green silicon carbide wheel to do it, but it's certainly possible. We do it all the time. And they definitely, well, I wouldn't say that they really wear. They usually chip or break before they wear because these things are just so darn fragile because the tungsten carbide is so hard and brittle. And you can see this one is actually, the cutting edge is pretty much destroyed on here. I mean, if you look at it from this vantage point, you can see that it's not straight across the end. And hopefully, looking at it from this angle, you can see that there are some nice big chunks missing from the end of the cutting edge right there. Okay, so this thing is chipped, and it's not going to give you a good cut, and certainly not going to give you a straight cut, meaning that your groove is going to have some, some weird shape to it, right? It's not going to be, a square recess. All right, so that's not good. This one is much, much better. It doesn't appear to be severely broken, right? But it does have a little bit of buildup right on that edge, right on the end. And that's something that we really should remove by grinding it back down. We just have to touch it up, okay? It's nothing major. And I'm going to go do that now. Okay, there we have it. You see, I touched it up on the end there. Right there, just gave it a little bit of a positive rake angle. Okay, just helps it cut a little bit cleaner. Also weakens the cutting edge, but these should last a while. I think that people just kind of abuse them. That's why, they get hammered up like they do. Now, we don't require that you go in and grind these yourselves. You can if you want, and we can show you how to do it, but it's not a requirement. We can definitely do this for you and maintain these tools. But one thing that we do ask you to do is just check to make sure that the cutting edges are good, right? And the other thing that we would recommend that you do is check to make sure that the cutting edge is relatively square to the tool. Now, I don't know if you can see that, but basically what we're doing is we're just taking some kind of a square, could be this little 4-inch combo square, and we're just setting the base on the head, on the side of the tool, and then just kind of bumping that blade up close to the cutting edge, and then we're just trying to look for, there should be a little bit of a gap in there, right, between the cutting edge and the blade, which is at 90 degrees to the head, and so if that gap is consistent, then we know that it's relatively square. It doesn't have to be perfectly square, right? It should just be mostly square, because we are going to align this on the part, right? But as you can see, like the two sides of the tool, they kind of taper back a little bit, right? And that's so that only the front edge touches and it doesn't rub behind the cutting edge, okay? But if you're cocked out at too much of an angle because your cutting edge is at too much of an angle and you had to flip it over really far in order to get it to be square to the part, then you're going to be cutting a chamfer on this side, right? And that's not something we want. So we have a little bit of adjustability, but it's not unlimited. So things to watch out for with these. Okay, so let's go ahead and pop this tool holder in there. I do recommend that you use a tool holder that doesn't have a V in it, okay, just because this is it's a kind of thinner than most of the other tools. And so, all right, first thing to do is to align the center height of the tool, and then we can put the part in and align the tool left to right to get it square to the part. So something like that. I'm going to use this method. Okay, is that good? Wow, it's already good. All right. That's a good omen. All right. I'll move it to this position. I'm not going to tighten it down yet because we still need to put the part in there. Okay. Now I'm going to do the chamfer tool. Okay, threading tool goes in here like that. Give that like one good tighten right there. Okay, that's a little bit low. Just a little bit more. Okay, looking really good. All right, lock that down. Okay. Now, to get the chamfer tool to be square, really we're just going to rely on the inside of the tool holder, right there, being square to these dovetails, right? So basically, if the tool post is square, then the tool is going to be square. And so that's usually just how we do it, right? Because we spent all that time making sure that those sides were 45 degrees on the cutting tool from the sides of the cutting tool. And so that was also that we wouldn't have to do any kind of elaborate alignment work with the tool itself when we got to the machine. Okay, so we do have to make sure that the tool post is relatively square in this case, but that's a relatively easy thing to do if we just remove the center and use the end of the quill for our adjustments. So extend the quill a little bit. Loosen the tool post. Bring it up to the quill. Okay. So bump the tool post up against the end of the quill and then lock it down. And that's certainly going to get us close enough. Okay, so chamfer tool is all ready to go. Its tool height is good and it's square to the machine. Now it's time to put the part in and get the grooving tool square to the world. Okay, make sure this is clean. Put the center back in and make sure that that's clean. Okay, make sure the centers are clean on the machine as well as on the part, right? Because if you're sitting on a chip, then again, this thing's going to wobble around. Okay. It's even worse than that actually, because if there's a chip in there and you squish that chip in there, then it's going to distort that surface in there, then it'll never run true again. That's no good. Okay. Lock that down. Okay, a little bit of tightness. Right there. It's perfect. Okay, so let's go ahead and square this up now. Now, I leave one of these sort of, say, a little bit snug, just so that we have a pivot point, right? Everything's easier if you give yourself a pivot point. If everything is just floating around freely, it makes it really difficult to make adjustments, okay? So I really just kind of bump this up against the part, okay? And then I visually align it so that the gap between the tool and the part is uniform from side to side, right? That tells me that they are aligned correctly to one another, right? The cutting edge is parallel to the part surface, and the tool is perpendicular to the spindle axis. That's basically what we're looking at here. This can be very difficult to see. So I'm zooming up here, and I'm going to show you a couple of tricks, okay? So, you know, if you can get a good visual just by looking at it like this, then, you know, good for you. But in order to improve the contrast, what you can do is, you remember these little books that we gave you, these little stare-it notebooks, okay? If you just put like a piece of white behind it, you can see that so much better, right? So then you can just kind of go in real close and just look at that gap right there, right? Is it uniform, is it not uniform, right? So like as I pivot this from left to right, you can see that, you know, so like here the gap is bigger on the right than it is on the left, and here the gap is bigger on the left than on the right, and somewhere in the middle is that Goldilocks sweet spot. So something like that. Let me go ahead and lock that down. Hopefully it doesn't move when I clamp it, but you know, it almost always does. How we doing? I mean, that looks pretty good to me. Another thing that you can do, right, is just use like a flashlight or something, right? Just give it a little bit of light in the back. Let's see. So sometimes you can just sort of blow it out. But you know, a little bit of light usually helps, right? Just tells you where you are. If you don't do this, right, if your cutter is going off at an angle like this, right, it's going to cut a tapered surface into the part. You're not going to have that nice square bottom to your groove, and that means that like it's going to measure something different on one side than it measures on the other side of the groove, and it's going to be hard to hit that size tolerance, okay, because it's like +0, -5 on these grooves, okay, so it's actually pretty tight. So it's really important that you do this and that you, you do it diligently. Okay, so let's see, that was steps number 1 and number 2. So all the tools are set to their height, they are square to the world, everything's locked down, ready to go. We made sure to touch up our center because we, removed it at the end of the day. Let's see, so now it's time to cut a groove. The first groove that we're going to cut is this one over here, the 663 thousandths +0 -5 and 250 thousandths width. And it's actually going to be right up against that shoulder that we already created right there that is 3 inches from the end. I'm going to set the spindle for the correct speed. Okay, come over here to approximately where we're going to take our cut and then do a quick little spin test. Okay, that looks good. We're not going to slam into anything. And then turn the spindle on. Now, this is potentially a little bit fast, okay? Because the tool can handle a pretty high speed because of the material that it's made out of. But this is not the most rigid setup in the world because we're only holding on to the small surface areas inside the 2 cones, right? And there's, like 4 inches of part that is unsupported, plus some length for the quill on the tailstock and the live center, right? So we have some unsupported length there. So not the most rigid setup in the world. So we may have some chatter in this setup, okay? But we'll find that out now. So here's what I'm gonna do. I'm gonna position the tool relatively close to the part surface like that, okay? And then I'm going to move to the left with the carriage just until I pull a little bit of a chip on that shoulder, that 3-inch shoulder that we already made. Be careful that you don't touch off too hard because it's going to move the position of the shoulder. Okay, right there. Here it's chattering a little bit. Now let me show you something. So hopefully you can see that in that corner there's a little bit of a radius, okay? And that's because the tool that we use, the right-hand turning tool, has a little bit of a tool nose radius on it, right? So it left that radius in that corner. Now we're going to be taking out that radius right now when we undercut this with our grooving tool, which has a square side, a sharp corner on it. But we have to make sure that when we touch off, we're touching off on the flat surface of the shoulder and not on that radius, okay? Because that's going to change our axial position, and then we won't clean up that radius fully, okay? We won't be cutting flush to the shoulder, if you will. Okay, so now I found my position, all right, on the carriage, and so now I'm going to set up an indicator so that I can record that position, all right? I'm just going to put that on the side here, just as we did before, but now I'm going to want to make sure that I adjust it, you know, I push the plunger in far enough so that it's kind of, you know, maybe in the middle of its range or something, because now what I'm going to do is I'm going to have to move to the right to make an adjustment to widen the size of the groove, and so I have to make sure that I have enough travel in the counterclockwise direction to be able to do that, okay? Start this up. All right, now I'm just going to feed in with the cross feed. You can see that I'm taking that radius out slowly, 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 and then all of a sudden I'm going to actually cut on the entire surface, and as soon as I do that, I'm going to stop. And right there. Okay, now I'm going to adjust the cross feed to 0. So hold the handle and move the little knurled ring, okay? And you can hear that it's chattering a little bit. This setup, like I said, is not very rigid, so we may have to slow this down, right, just to keep it from chattering. So how far in should we go? Okay, so this is 745, this diameter here, and we're going to get down to 663. So where I just touched off on this surface, how much further in do we need to go? So 745 minus 663, 82 thousandths of an inch. But I'm not going to do that all in one go, okay, because I have a pretty tight tolerance on that diameter. So I'm not going to plunge in 82 thousandths and hope for the best. I'm going to plunge in, let's say, I leave myself 5 thousandths, okay, or maybe even 10 thousandths, right? So I'm going to go in 77, I'll go 75 just so that it makes everything nice and easy and clean, okay? And then I'm going to retract and take a measurement, all right? And then, based on that measurement, I'm going to go in however much deeper I need to, okay? Because who knows how much I just took off right here, right, where I actually touched, right? So really what you want to do is take a cut to establish a position and then measure that and then go from there. That's what we're trying to do in all of these steps here. The other thing is, and actually I'll discuss this more in just a moment, but the width of our cutter is not 1/4 of an inch. So we're going to have to move it over some amount in order to widen the groove, which is why we set this up, right? But that's something that we're actually going to have to measure off of this tool, because each one of these tools is different, right? Because each one was hand ground in order to sharpen it. Okay, so that's another thing that we'll do when we retract this after our initial cut. So let's try this out. I'm going to give it a little bit of coolant. Okay, 75 thousandths. Actually, it's cutting really nicely. That's 75 thousandths right there. Okay, so pull it back. So what if we tried to get a micrometer in there? Is that going to work? No. The contact points on the micrometer are just too broad. They're not going to be able to get down into that groove. So what are our other options? Well, we could put a dial caliper in there, right? That would fit. Actually fits quite nicely, right? Problem is, this is nowhere near accurate enough to be able to measure down to a tolerance of 5/1000ths of an inch. So that's not good either. But wait, what's this? Oh, this is a blade micrometer, okay? It works just like a regular micrometer, except that you can see that the contact points are very thin, almost blade-like, if I may. And one kind of cool thing about this is that in order to make this whole arrangement work, right, this is a non-rotating tip, as opposed to most micrometers where the spindles rotate, right? I mean, if this rotated, then it would kind of defeat the whole purpose, right? So that's pretty cool, okay? Still have to zero set these, like so. Okay, very good. All right, let's open this up and take a measurement. Not only does this let us get into the groove, but it also allows us to measure multiple points inside of the groove, right? So if I'm measuring all the way over to the left, what do I get? I get 666 and a half, is what it's telling me. And over here, what am I getting? Wow, 668 and a half. So I thought that my alignment was a little bit better than that. Okay, but I'm 0.02 from side to side. That's not awesome, but we can still get inside of our tolerance, right? As long as we're inside of our tolerance on both sides, right, everywhere inside of the groove, then we're okay. The closer our alignment, the less tapered this surface is, the easier it's going to be to hit that tolerance. But we could technically be 0.05 out from one side to the other, as long as one side was at the lower limit, the other side was at the upper limit, right? Okay, so this is going to be fine. I'm going to go with the higher value here, the 668 and a half, because I know I need to be at least a little bit under 663, right? Because it's a unilateral tolerance, plus 0, minus 5. So to get from 668 and a half to 663, I'm going to have to take 5.5 thousandths. But maybe I'll go in like 6, okay, just to make sure that it cleans up everywhere. The other thing that we need to check is the width of our tool. I'm going to have to move this over a little bit to get that measurement. Could have done this at the beginning. Okay. Okay, what's it telling me? What's it telling me? So that says 175 plus 11, 186. So 250 minus 186 is 64 thousandths. That's how far I have to move over with the indicator on the carriage in order to widen this groove out to 250. Okay, so that's what we're going to do. So what I'm going to do is actually, so here's my starting position, right, where the left side of the tool is actually on the shoulder. So now what I'm going to do is just move over that 64 thousandths on the indicator. Okay, so that's 10, 20, 30, 40, 50, 60, and 4. Right? Okay, you saw that we had to go negative, right? So, because we're moving the carriage this way, so we had to go from 0 towards the negative direction counterclockwise. And so we're not going to stop at 64. We're going to go 0 minus 64, which actually puts us at 36. That make sense? I hope so. So this is the little dance that we're going to do, okay? Now that we've moved over, we're going to plunge back in the rest of our depth to get down to our final size, and then we're going to feed from right to left just to clean up that entire surface and then retract, okay? So this is the waltz, right? You go in, out, measure, over, in, over, out. In, out, measure. Over, in, over, out. Right? It's fun. Here we go. So you can see it's cleaning up that side. So this is where I stopped last time, and I'm going to go another 0.006. Right there. Okay, feed back to my 0 on the indicator. Okay, and now I can feed out again off the part. That's it. That should be good. So this surface finish is not, I mean, it's okay. It's not as good as I would hope. And that's because the steel is tearing a little bit. It could be, I have to play around with the feeds and speeds. I didn't add any coolant this time, so coolant might be part of it. It could just be that also this edge here is actually not as sharp, or maybe it's more jagged than I originally thought when I went to go grind it. So there are a number of things that can happen here. This is not a problem here in the bottom of the hole, but it usually comes out better than this. But I think it's okay. Okay, let's take a measurement. Over here, what do we have? You have to be real careful because this thing, because the contact points are so small, you can easily get it knocked out. I mean, you can easily read diagonally when you really want to be reading straight up and down across the diameter. You just have to be careful. Just rock it around and make sure that you're right where you want to be. So this is telling me 659.5. Okay, that's fine because 663 minus 5 is 658. Right? And so we can be as small as 658. So we're still 1.5 thou, almost 2 thousandths over that lower limit. What do we have over here? Okay, and over here we've got 662 and some change. So 662 and whatever, 0.8. Okay, so right at the top of the range, but still within the range, right? And so the better this is aligned, the less tapered that surface is going to be, and the easier it is going to be to nail that tolerance, okay? But it's not like you can't do it with a little bit of a taper. You just have to watch out for it, okay? Okay, folks, moving right along, let's go ahead and do the other groove, okay? Move this in a little bit. Turn it on. Okay, I'm going to move the carriage to the left just so that I touch off on that shoulder very gently. I don't want to move the position of the shoulder, I just want to touch off on it. This is called a dynamic touch off, right, where the part is spinning when we touch. That's perfect right there. Go in and set the indicator. Right there is fine. Oh, it's a little bit cocked. There we go, 0. Turn it back on. Okay, I'm going to go in until I just touch off on that surface. Okay, getting pretty close. Okay. Set my 0 on my crossfeed. Okay, I think I'm going to actually slow this down a little bit just because it's not behaving very nicely. Okay, so let's do the next slowest speed. All right. Now, this was, what was this? This was 618 thousandths. And I'm going to get this groove diameter down to 497, plus 0 minus 5. Okay, so that's 618 minus 497 gives us 121 thousandths. Let's take 10 thousandths off of that, so we leave ourselves about 10 thousandths to play with. That's 111. Let's say 110 or 115, okay? Just leave yourselves a little bit of material on the bottom there to clean up. And don't leave too much, okay? Because these grooving tools really don't want to cut side to side. All right? Okay, here we go. let's feed in 110. Right there. Yeah, definitely still chattering a little bit. Like I said, not the most rigid setup in the world, but I don't know. Surface finish looks okay. Okay, clean this off a little bit. It got a little bit dirty. Okay, take that measurement. What is that? That's 504. So over here, it's 506.5. Okay. So 506.5 minus 497 gives us 9.5 thousandths. Okay, but let's go 10. Okay, maybe 11, just to make sure that we're under the top of the tolerance, right? It's 497 plus 0 minus 5. So we can be a little bit smaller, but no bigger. Okay, so let's go 10. Okay, turn this thing on. Okay, we got to move over on our indicator, right? Still 64 thousandths, just like before, because the width of the groove didn't change, but the diameter did. Okay, so I'm going to go back into my 110 position on the cross feed. And remember, I'm going to go another 10. Let's try giving it a little coolant this time and see if it calms down a little bit. Okay, feedback to my 0 to the left. There we go, and then pull out. Okay, let's take that measurement. Okay, what are we getting right there? So it's telling me 475 plus 18.5, so that's 493.5. Okay, that's still good. So remember, it's 497 plus 0 minus 5, so 497 minus 5 is 492. Okay, so we're 1.5 thousandths over the bottom of the tolerance. About what we had on the other groove, right? Very good. Very consistent. Okay, this side. So that says, yeah, so 475 plus 21, so 496 plus, I don't know, looks like 6/10 or so. Okay, so just under 497, but we are under, so this is good to go. Okay, so that's it for this tool, although there's something that I should mention, actually a couple things that I should mention. In the process of adjusting this tool so that it would be inside of the camera frame, I had to back the compound out like this. Okay, and that exposed more compound slide on the end of the compound, right? Now this is, I mean, it's okay to have a little bit exposed, but I thought I should mention that if you have too much exposed, then you run the risk of running into clearance problems. Okay, so let's think about this here. So let's say that I was real far back like this, okay, and I come over here and I'm cutting my part, okay, and that's all fine and dandy, but what about the rest of the compound? So here I'm doing a spin test, and it doesn't look like the lathe dog or the chuck jaws are going to slam into this area down here at the bottom of the compound. But if I were a little bit further back, or if my compound were at a slightly more aggressive angle, then I very well could be intersecting the lathe dog or the chuck jaws or even the chuck itself, right? And that's actually a pretty common mistake that people do. I don't know if you can see this that well in the camera, but over here, here, all through here, there are chunks missing from the end of the cross slide, or the compound slide, right? And that's because people were doing exactly what I just said, right, and weren't looking out for the clearance down here. They were only looking out for the clearance of their tool on the side of the tool holder, right? And that's how we get these chunks missing from the parts of the lathe, right? So something you have to watch out for, okay? If at all possible, you should have the end of the compound and the end of the compound ways sort of just flush to each other, okay, so that you don't run into this issue at all. The other thing that I should mention is that, how would I get this closer, right? I mean, this tool closer aligned to the part, right? I could just, I've got a camera in my way, and so I wasn't really able to get my head down in there and make sure that the thing was correctly aligned, right? But another way that you could get this a little bit closer, instead of just doing it visually, you could use a shim, okay? Doesn't matter what size the shim is, okay? But here's how this works. If you put the shim in between the part and the tool on one side, and then you move the tool slowly in until it just starts tugging on the shim. Okay, hold on, wait for it, wait for it. Okay, I can just feel it touching right there. Now what happens if I try to get it in through the other side? Ooh, it won't go in. So wait, it'll go in through one side, but it won't go in through the other. That must mean that the front of the cutting edge, right, the cutting edge on the front of the grooving tool is not square to the part surface, right? So you could just adjust this until the shims drag at the same location on both sides of that cutting edge, and that's a pretty sensitive way to check for this. I mean, this is the same way that we, set the 0 on the height gauge, right, on the surface plate, right? So this is a very sensitive trick that we use. It's using a shim for a positive touch-off. This is a very common way to do these kinds of sensitive alignments and sensitive touch-offs, right? And so that's one way that we could do it. Just thought I would mention that. But anyway, we are done with this grooving tool. And we are on to the chamfer tool. Okay, we are on steps 5 and 6 right now. The last two steps in this relatively short stage right here. Okay, 5 and 6. So we're going to do the 58 thousandths chamfers first. So we've got 2 times 58 thousandths by 45 here and here. 2 times 41 by 45 here and here, okay? So remember that because there is a coarser thread on this diameter than on this diameter on the final part, the threads themselves are going to dig deeper into this material than into this material, and so we're going to have bigger chamfers here and here, okay? So we're going to do these first, just so that we can start from right to left. Actually, it doesn't matter which one you do first, but it just feels right, So if you'll see in your tool list here for this step, the 58 thousandths chamfer step, it calls for some 2,000 shims, okay? Now the shims that we're going to use are these shims right here, okay? They're just regular shims, but they've been cut into thin little strips, okay? And this is something you'd get from your instructor, okay? And I will mention this in just a moment, but we'll do that on the second chamfer that we cut. For this first chamfer, on the very end of the part, all I'm going to do is position my tool relatively close to the live center here. You don't want to dig into the live center, obviously, okay? And you're going to position this left 45-degree cutting edge close to that corner, okay? So all we're going to do is touch off, and then we're going to feed to the left 58 thousandths. That's all we have to do here. It's not very complicated. We just have to make sure that we're far enough in so that we can cut a full chamfer on that entire corner, instead of, if your tip is not far enough past the corner here on the part, then once you get past the tip on the tool, like if you're feeding to the left, then once you get past that tip, you'll just be turning a straight cylinder, right? Just a diameter. That's not what we want. We want to put a nice big, diagonal cut on the end of that part. Okay, so this looks like a good position right there. Okay, I'm going to set this to the appropriate speed, which again you should have calculated yourself. Turn it on. Okay, so I'm going to feed the carriage to the left just until I take a tiny little cut on that corner. That's where I'm going to touch off. Right there. Okay, and go ahead and stop it. Okay, now it's time to set up the dial indicator. Just as we've been doing this whole time. Okay, set it to 0. Ooh, little chip right there. Okay, turn it back on. And we're going to feed to the left 58 thousandths. I'm going to use some tap magic here. We're running pretty slow, and this is a nice broad forming cut with high-speed steel, so this is an appropriate time to use cutting oil rather than coolant. So I'm going to feed to the left. You can see that that surface gets bigger and bigger and bigger and bigger and bigger as we get further to the left, and then right there is 58 thousandths. Done. Could not be easier. Okay, the next one is just a tiny bit more complicated because it's going to be over on this side, right? This side of the diameter right here. And in order to cut 58 thousandths, we need to get really, really, really close to that groove diameter, right? In fact, what we really want to do is get right up next to it, right, so that we can blend that chamfer in flush with the bottom of the groove and the outside diameter here, okay? Problem is that if you just try to do that by eye, right, then you're very likely to either not go far enough or to go too far, and then you'll cut a little groove with the end of your chamfer to a little sharp pointed 45-degree or a 90-degree groove into your nice square groove that you just spent all that time putting in there, right? And it's going to totally mess that up. So how do we get close enough without getting too close? Shims. And of course, the reason why these were cut to a smaller width is so that they could fit inside the grooves. So just like that. Gosh, we use a lot of shims in here, don't we? All right, here we go. Kind of moving it up and down just so I can feel when it starts to drag. I'm going to slowly move the chamfer tool in just until I can feel it touching. All right, right there. See, it retains the shim right there, but I can easily pull it out. So that's perfect. Okay, turn it back on. And feed to the right just until you touch off. Now touching off on the right side of the chamfer tool. There we go, just a tiny little chip. Stop it, put the indicator in. Make sure that you're somewhere in the, the middle of the range or about there for the indicator, just so, because we're going to be feeding to the right again this time, just like we were with the grooving tool, and so we're going to be feeding counterclockwise on the indicator. So just have to make sure that the plunger has room to come out, basically. Give it a little bit of tap magic, magic sauce, and then feed it to the right 58 thousandths. So that's 10, 20, 30, 40, 50, and 8 right there. Okay, and that's it. Now remember, since we're going counterclockwise, okay, we didn't stop at 58, right? We went 0 minus 58. So we went to the 42 on the indicator. Okay, important to remember. Okay, go ahead and clean this off. And that looks pretty good. You can see it blended in really nicely with the bottom of that groove. Awesome. Okay, let's do the next one. Okay, we don't have to worry about the shims for this side because, we can get just eyeball close to that groove down there. And still have, be far enough in to get the, what is it going to be? It's a 41 thousandths chamfer now on this surface right there. Okay, turn it on. Feed to the left. Now we're going to have to go a little bit closer, I think. Okay, touch off. Nice and slow. All right. You only have to just shave that corner to touch it off. Don't touch off too heavy. Okay, this is set at 0. We can turn this on. Tap magic. 41 thousandths this time. 10, 20, 30, 41 thousandths. Beautiful, awesome. Nothing to it. Let's hit up the other side. Okay, take our friend the shim, touch off on the bottom of the groove, nice and easy. Oh, there we go. That's probably a little bit too much, huh? Like really jammed in there. Okay, I'm going to come back into it. Okay, perfect. Still retained, but slides out easy. Okay, let's turn the spindle on. Wow, how embarrassing is this? I was lulled into a false sense of security because of my prior successes, and I didn't even bother to check my clearance between the tool holder and the lathe dog. I did not do a spin test. Wow. I'm going to keep this in the video just so you can see how easy it is to make this mistake. Okay? So, let's try this again. Luckily, there was no damage, but there very well could have been. So, I can see now that we're super, super close there with the side of the lathe dog. Okay? So, here's what I'm going to do. I am going to loosen the chamfer tool, and I'm going to just move it out a little ways. That's going to give me just a little bit more clearance to the side of the tool holder, just enough so that I can make that work for me. So as long as you have this like lined up with the side of the tool holder pretty well, then it should be still square enough. But it may be better to grab something like this, like just a little aluminum shim, and stick it behind the tool, like so, and then just bump it up against the inside of the slot for the tool. Okay, that's just going to keep you nice and square. Tighten that down again. Okay, gosh, let's try this again. All right, that's looking good. Close, but good. So after giving students so much gaff over the years for making silly mistakes like this, and then I go ahead and do one of these myself, I don't even know sometimes the person I'm looking at in the mirror in the morning. Anyway, let's set this back up. All right. There we go. Turn it on. Okay, feed it to the right just to touch off on that corner. There we go. Put that indicator in there, about halfway through its travel. Like so. Turn it back on again. Okay, a little tap magic. And feed to the right, 10, 20, 30, 41 thousandths. Okay, there we go. That's all there is to stage 2, the grooving and chamfering stage. Okay, so at this point, I can back off the tailstock, like so, wipe off the part, and there you have it. Part is ready to go for threading. Okay. Now, if I just left this setup like this, I could just start threading right now. I don't have to break this setup down, right? But it's very likely that at the end of the day, this is as far as you will have gotten, and so you'd have to break down the whole setup. Then you'd have to put this back into the 3-jaw chuck, and you'd have to do what? You'd have to retouch it so that it's running true, right? So that when you put this back in, it repeats perfectly. It's going to be very important with threading because you don't want this surface here running out compared to the threads, right? That's going to make it really, really difficult to get good threads, right? The threads themselves need to be very concentric to this diameter. Okay? Anyway, thanks for watching. That's the end of this video, and join me next time for part 4 of this video, the final part in which we cover stage 3, threading. See ya.